no matter it is a oriented graph or only a table, you will be able to extract its requirement and its destiny from the statement. What is ultimately? Ultimately, I need to obtain system admittance bus given the information in the form of table as well as in the form of graphical representation. Now, my next task is to understand the table carefully. How many elements of this system are directly given to you? How many elements of this system are mutual to each other or one another? That information you must trace carefully from the given table. Hope you are able to get this table very carefully. You have to read very carefully. Elements, how many are there? Are they really there? How many elements are given with the admittance or impedance? You must check carefully. Here, attention is, this data is in impedance, but I require A transpose into Y primitive into A matrix to get the Y bus. I require admittance. From this impedance, I must be able to get admittance by inverting impedance matrix to get admittance matrix. We will see step by step. So that's what the attention impedance is given. Then mutual impedance is given. So this domain is mutual. I mean impedance. This is in impedance notation only. J.1 ohm is an impedance mutual between bus element number 2 and element number 1. Again J.2 ohm, the mutual impedance between element number 4 and element number 1. Let that few more elements may be given, need not be given. If it is given, I should take care. If not, whatever is given, I should take into consideration and I should go. Now, let us start with the work. We know that. What is the next step? We know Y bus of a system is equal to A transpose Y primitive into A. This is a basic formula. Now, for me, I need to frame A, which is a reduced impedance matrix, and take a transpose, keep ready, and obtain Y primitive matrix. So, Y primitive matrix, what is the Y primitive matrix?
Excuse me, sir.
Please come in.
Sir, many of them are unable to join, it seems. Please accept them.
Okay, just sir has just gone out. I'll try. Okay. Sir has just moved out. I'll just try. Okay, fine. Let's request me again so that I can.
Thank you, sir.
I'll do it. 15.
Okay, sir.
Okay, a minute. Already 15 are there. I think, yes, I'll accept them if they come. Okay, I'll accept it. Sir. Okay, sir is back. He'll accept it. Okay, no problem. So, let us understand what is YPRI. So, I'll just give you the principle. Admittance form of primitive element is inverse of Z primitive. Can you see this line? This is a new line which you will be knowing the relation between admittance and impedance. Primitive impedance matrix, if I have, inverse of that if I take, it becomes admittance matrix. Now, why we have been focused this? You can see here, impedance is given, you have to get admittance, then it is necessary. Now, my task is to prepare ZPRI first. So, I'll prepare ZPRI. Then what is ZPRI? Primitive impedance matrix, like a primitive admittance matrix of a given problem having number of rows, number of columns equal to number of elements in the system. The properties look similar to the Y primitive matrix, but elemental data is in the form of impedance. Rest of the arrangement, all the elements are put with diagonal position. The off diagonals are surely 0 if there is no mutual coupling, and few of them will be non-zero only for those mutual coupled case. The principle of Y bus, whatever we have referred, it is truly applicable to ZPRI, but representation will be in the form of impedance value. So therefore, how many elements I have in this problem? Total 5 elements. Then this matrix shall have a dimension 5. Let me write it here. 1, 2, 3, 4, 5. Let us put a bracket over here. Then it will be having 5 elements. 2, 3, 4, 5. Let me close later. Okay. Now, what is the elemental data of 1? Element number 1 having how much of information? J.6. So it will be J.6 in 1 cross 1 position. What about element number 2? Let me put first the diagonal. Later we will come to this. Okay. 1. And what is 2? J.2, J.5. Then 2 cross 2. Here comes J.5. Then how about element number 3? 3 cross 3. I am following the principle of YPRI as it is, but values which I am placing them on the diagonal for impedances. Hence the dimension is ZPRI. So the third element is J.5. So I'll go here. I'll just come in. J.5. How about the fourth element? 0.4. 4 cross 4. This is J.4. Then how about the fifth element? J.2. This is 5 cross 5. I come down. J.2. Okay. I just do it. J.2. Just I make a bracket complete. Then I'll place 0, 0, 0, 0 like an original concept. Later I'll edit it. Okay. Then I've just done. This was the original work what would have done in YPRI? Yes, absolutely right. Okay. Like this. Now look into this. This and this. So without these things, this matrix would stand as Z primitive, from which you would have obtained inverse to get the Y primitive, which is very easy. But the case is not so. The case is mutual coupling is there. Then where to look at this? Where to write this information? This you have to see. Element number 2 is mutually coupled with element number 1. 1, 2, there is a coupling. Then in this matrix, I should check row 1, element number 1, and column element number 2. Can you see this? Row 1, column 2. This element is non-zero. The what value it should be there? The value which is mentioned here. So element 2 and element 1 are coupled by J.1. Hence 1 cross 2 will be J.1. So if I do 1 cross 2, 2 cross 1 also need a correction. What about the 2 cross 1? This also go non-zero. Just observe, one mutual coupling will have 2 non-zeros. You can just see now, I interpreted J.1 mutual coupling between element 2 and element 1 in this Z primitive matrix in the row number 1, column number 2, 1 cross 2, J.1 non-zero. Similarly, coupling is bidirectional. 1 is mutually coupled with 2, 2 is mutually coupled with 1. Therefore, row number 2, column number 1 also need non-zero entry. For that non-zero entry, I should check J.1 appear here also. Can you watch this? 2 cross 1 is also same mutual impedance J.1. So J.1 in 1 cross 2, same J.1 is in 2 cross 1. That completes mutual coupling information of first element. Element number 1 is coupled with element number 2. That is being done. The same work I should check with this. What is this? Element number 4, element number 1 have a coupling. It means to say 1 cross 4, 4 cross 1. I should tamper. Then I should say 1 cross 4. This is non-zero. By what value? 4 is coupled with 1 by value of J.2. Then 1 cross 4 is J.2. One work is over. But coupling is 1 to 4 and 4 to 1. I should, without fail, I should check similar 1 cross 4 in the position 4 cross 1 also. Then 4 cross 1. This element need modification. I am doing basically because first I dumped 0. Later, I am trying to convince you where all these entries appear. If you become familiar now onwards, no need to fill zeros. Wherever there is a non-zero, directly position non-zeros and remaining you keep them as zeros. It becomes little advanced to you. So you can definitely do that. So can you watch my complete ZPRI now? It is a full house matrix of 5 cross 5. Usually we should have all the elements on a main diagonal, and upper triangle, lower triangle used to be 0. But now because of mutual coupling, 4 elements, 1 cross 2, 2 cross 1, 1 cross 4, 4 cross 1 are non-zeros. You have 4 extra elements in the system. Okay. May I know, many of you are not able to join. Why? What is the reason? May I know? Someone in the group? But no one is trying to log in.
Sir, it is a link problem or maybe a Google server problem, sir.
Okay, fine. Okay, okay. But I have seen 18. Now they are joining. One by one they are joining. Okay. So now they are joining. The count is increasing.
Sir, Jyoti Kerudi is trying to join, but it is not. It's not happening, sir.
So now shall I stop and join, or what is the best way?
Sir, if there is a pop-up of accepting her joining, you can accept it.
That's what I can do. Now 18 count is increasing, but there is no pop-up message that accepting to, waiting to enter the hall or something. That is not coming to us.
Then that means a server problem, sir.
Okay. Anyhow, this video will be there. I can share video also. It not be a matter to me. So those who really want, let's keep on attending me. And those who really close the dial. Yes, someone is joining. Yes. Okay. Join with college view email, sir. Okay, that's correct. Gmail only you are klit.ac.in you are trying to log in. For that, entry is direct. We need not even make them to enter. Auto they are entering. Only non-email fellows are given a permission. Okay. Okay, you can try. Some more, you can pop up to me, and if I get a message, I can admit them. Okay, Dandil sir is here itself with me. He's trying to admit it. So let it pop up. That's the request. Okay. Meantime, so we were here. I could frame Z primitive matrix with mutual coupling entries. Diagonally, I have elemental impedance, and off diagonal, I have mutual coupling. Those many elements were said coupled, that entries were made non-zero in the matrix. Rest, it looks similar to the observation. Now, what is my next task? My requirement is YPRI. What I should do now? ZPRI inverse. Inverse of this matrix is necessary. Now, there is a technical challenge. Your calculator cannot do an inverse operation more than 3 cross 3 dimension. You might be aware of this, maybe practice in network analysis or somewhere where you are likely to come across matrix, or in mathematics also. So we need to have some Gauss-Jordan method or Gauss elimination method or diagonalization method, some analog techniques which you have to reuse them. So therefore, this 5 cross matrix, 5 cross 5 matrix need a inversion. So inversion is not possible directly from the calculator. If you had only the elements on diagonals, no entries in the off diagonal, one by one inversion would work for you only in that case, non-mutually coupled. But when it is a mutually coupled case, surely you need to adopt an alternate method. Okay, so the Gauss-Jordan method, Gauss elimination method, diagonalization method, and triangularization or triangularization method, whichever you have, those are the methods which help you to get inverse of a large sparse or space matrix. Space techniques you might have learned in M3 or M4 of your lower semester, I guess. So those techniques will be useful to you to get the inverse of a large matrix. Okay, that will get to some such methods also. I'll share to you. You can make use of them. So my focus now is to get this information in the form of a matrix. Next is to get inverse of this to obtain y primitive. So if you operate y primitive by alternative techniques, what would be the answer? So because I have this solved this already using MATLAB with the support, because it is quite easy in the MATLAB. In the MATLAB, if I just run ZPRI or some element Z equal to is INE Z, give me the inverse of this matrix on a single click in the MATLAB. In the laboratory part of the work, such one example you are going to solve. Obtaining y bus by insertion method, in singular transformation method, with coupling, without coupling in the MATLAB. There we have command line given to you, computer given to you, directly you can run it, you can execute, copy and go ahead with the numerical solution. In the laboratory, you will be given freedom of use of computer. But here you need to, in the main examination I am speaking, you have to have a technique to work with. So therefore, if I would have taken an advantage of MATLAB and I could do it, I have the answer with me as this. So this led me YPRI has how many rows and columns? 5 rows, 5 columns. Let me write it. So you can get to this and you can even think of, if you can try in a MATLAB also, you can do. The first element works out is minus J 2.0833. I write column wise. It will be easy for you to access. Okay. First column J 0.4167. 0. Next is J 1.0417 and the last one is 0. These are my inverted first column values. The second column will be the same reflection J 0.4167. The second is minus J 2.0833. The third element is 0 and the fourth element is minus J 2.0833. Then fourth element is 0 and the next column is 0, 0 and entry over is minus J 2.0. The next element is correct, third, and it should go up, one up here, minus J 2.0 and this will be minus J. Please convey me.
Sir, video is not clear, sir. It is blur, sir.
Maybe that's the reason. Maybe your friends are not able to gather on my screen. I just write it. I'll wait a moment also. May it will improve a little. Okay. Maybe that network issues. Your friends are not able to join. Let me write this one line, and I shall wait, and I shall confirm and go. Okay. That I can do. Okay.
Okay, sir.
One line, I'll stop and I'll discuss with you. Maybe network issues at our side also may matter, 2.0 and this is 0, 0 and the fifth column I have fourth column I have J 1.0417. The next is minus J 2.0833. Next is 0. Next is minus J 3.208 and fourth is 0 and the last column is 0, 0, 0, 0 minus J 5.0. I stop here and I will watch for your quality of video and just your kinds of conveying me. I'll just turn back and see. This is exactly YPRI. Now I'll just come back to the screen. Now, can you see some change there? Someone in the group, can you see some change in the video?
No, sir.
A small change you notice, or shall I adjust it?
Still it is blur, sir.
Blur, no? Okay, I'll just make an adjustment. Please watching me. A change, blur is going on or clarity is coming up? Blur, I think blur is increasing.
Yes, sir. Blur is increasing.
Now there may be some change, I think, this time, this moment. I think this current position might be good, I guess, compared to the earlier one.
No, sir, it's still blur.
Okay, I'll still adjust. Now you please try. Just a minute. Now you try, please. It must be clear now, I hope, comparatively. Because this computer is given 50 Mbps broadcasting ability. All these three computers in the department for the classroom activity, 50 Mbps line. Express like highest speed is allocated to these computers directly with some protection. So there shall not be any delay from our end. If network issues are there, we shall accept it. That may be the reason. Now I think as per me, I find a small change on my screen due to this small magnification I just tried on the camera's neck by making the lens adjusted also, and movement of the camera a little bit forward I did just here. I am personally getting blur here in my screen now. Personally, I am getting totally blurred. I am just making clarity. Now it's more clearer to me compared to the previous adjustment what I am doing. Okay. Still, I'll go ahead fine tuning. I think still better I am getting now here. I'm just trying. I think my side whitening is going on. Slowly whiteness is added to screen now. Blur. For me it is blur now. Now it comes back to the good position for me. Now I think this is what right now I am finding very clear compared to my 3 to 4 trials that I could do. Just see. Anyhow, this video I will be sharing to you. You need not get any worry about that. If only worry is, are you really able to find this complete coverage of the board? If you could get that, I can share this. These I am sharing in the classroom, my link which I am trying to provide you. It will be there without fail. Okay. Just a minute. I'll adjust also. Okay. Now somebody can you hear me? Is this particular current position is acceptable or still worse than earlier what we find? At least are you able to get this? I think you are able to notice the change. When I move the camera, the greenish board you are able to see. When I move away, focusing to the board. So my interference with the line of sight also matter over here. Now I think you must be able to see clear, I guess. Someone would confirm me. It is visible now.
So it is bit visible clearly, sir.
Compared to the earlier what the problem we started, is it
Yes, sir.
comparatively okay this time? Okay.
Yes, sir. Now
This video will be shared to you. No need to worry. Let me confirm. These board edge to edge write-ups are visible to you. That makes my writings on the board transfer to you. Later you can make out it from videos also, which I'm going to share. Okay. So just I'll come back to the board. I was over here from this ZPRI using the best methods of numerical solutions, obtaining a large matrix inversion. We should obtain inverse of a matrix. Once you obtain, you are ready with the YPRI. If this YPRI is ready, go to your basic equation. What is your Y bus? Y bus is A transpose YPRI into A. You prepared this one. This is ready now. You prepared it. This is what the partial work you have done. Now you have to obtain A matrix, take A transpose, take a product of that. That is the pending work we have to do. Now to do that, you have to learn what is that incidence matrix. What is that reduced incidence matrix? For that, we should get oriented graph. From this oriented graph, we should obtain A matrix, and from that A matrix transpose and put the string in the product. So I take out the board, I wipe it out, I just focus myself to obtain matrix A of this. Then for the matrix A, I require oriented graph. This is required. I keep this, rest of the portions I wipe out. So that A, YPRI and A transpose I make use for my next operation. Okay. I just clear the board leaving this matrix. But I'm sure impedance what was given now got transformed into primitive admittance. So temporarily I keep this as it is. Okay. Just for observation. Now my next work is A matrix or A cap. How many elements are here? 5. Let me make it 1, 2, 3, 4, 5 elements. How many buses are there? 1, 2, 3, 4. Which is your reference bus? 1. So 1 I will not write. I make it 2, 3, 4. Hope you are able to understand me. Why I did not wrote 1 here? 1 I did not wrote because personally I want to prepare A matrix directly, not by A cap. A cap I am avoiding. To avoid that, my next step is make it one column eliminated in the advance. So I use the rule. What is the rule? You remember? Rule is Aij is +1, Aij is -1, Aij is 0. An ith element incident to jth bus or a node oriented away from that is +1. Ith element is incident to jth bus oriented towards j is -1. Element number I is not incident to jth bus or a node, hence it is 0. So this rule I have to apply column wise. Go to bus number 2. This is reference, I am just crossing, I am not doing anything for this. I come to this bus. So at this bus, how many elements are there? 1 is inward, 4 is inward, 5 is outward. Then I should say at bus number 2, here I have n buses, here I have elements. Number of buses, number of elements. So n and here. So this I'll be taking care. So now at bus number 2, how is the bus number element number 1? Inward. Second rule applies. This -1. How about element number 2 here? Bus number 2, element number 2. Not incident. 2 is not incident to bus 2. I just position here. How about element number 3? Bus 2, element 3. 3 is here, not incident. This also goes 0. How about element number 4? Element number 4 is incident and towards the j, towards number 2, hence it is -1. How about element number 5? Incident but moving outward, it must be +1. So you have 3 non-zeros. 1, 2, 3. Physically 3 elements non-zero. 1, 2, 3. Then we should check 2 are incoming, must be 2 minuses. 1 is outgoing, 1 of them is plus, which is there, which is witness to. This is how you have to frame A matrix directly with the rule. So observe, I am not doing a cap, I am doing directly A. Bus number 1 is removed personally from the beginning only. Then I will go ahead with bus number 3. Where is the bus number 3? 3 is here. At 3, how many elements are there? 2 is inward, 3 is outward. 2, 3. Rest all are 0. Therefore, I should write bus number 3. Element number 1 is here, 0. Element number 2 is inward, rule 2, minus 1. Element number 3, outward, rule number 1, plus 1. Element number 4, rule number 3, not incident. What about element number 5? Not incident. Clear? Directly we can frame. Now similarly you move to next bus here. Bus number 4. What you have? 3 is incoming, 5 is incoming. Remaining elements are not connected. So 1 is not connected, 0. 2 is not connected, 0. 3 is connected and inward. Inward means minus 1. And 4 is not at all connected. 4 is here, but 4 is here. Not incident. 4 is 0. How about 5? Inward. And it is rule number 2, minus 1. So this is ready. You got A, you know YPRI, take A transpose, multiply and get the answer. This is how a mutually coupled case also need a simple approach of getting A matrix, A transpose of which, Y primitive of that, we need to work it out. So therefore, if I put all together in a matrix, let me put here, therefore, I write here, therefore, Y bus is equal to, what is A transpose? This I write as row by column. This works out as matrix like this. A matrix how much? Minus 1, 0, 0, I write it lower, minus 1, 0, 0, minus 1, 1. I write 0, minus 1, 1, next is 0, 0. The third row is 0, 0, minus 1, 0, minus 1. This is A transpose and YPRI. YPRI, what is the matrix YPRI? The same matrix I copy, paste over here. It is what? YPRI. So let me write it. I'll not worry, I'll write once again. This will be minus J 2.0833. Then is J 0.4167. Next is 0. Next is J 0. Not 0. J 1.0417. The last column is 0. This is your full house matrix dimension. Into A. What is A matrix for you? I write in a very short way. Hope I am covering this cover. It's coming. Yes. Matrix A is minus 1, 0, 0. I'll check it out. This is 0, minus 1, 0. Just to check space arrangement, I am just trying this first. 0, 1, minus 1. This is minus 1, 0, 0. This is 1, 0, minus 1. It's assembling. And second row, I copy paste here. J 0.4167, 0, J 1.0417. This is 0. And second is minus 2.0833. Okay. This is 0. This is minus J 2.0833. Last element is 0. Here I have 0, minus J 2.0. Here I have 0, 0. I'm copy paste this. I'm just taking the content of this over here for the physical position of right axis. Okay. So if you are doing it already on your paper, okay, or you can make a snapshot of it, you can take it as a reference for 833 and 0. Here I have 0. Here I have 0. Here I have minus J 3.208. This side I have 0. Here I have 0. Here I have minus J 5.0. Hope I am covering this. Exact Y PRI I have pasted here. I just take it out. This is not required for me now. Okay. So I obtained from this matrix A transpose Y PRI into A. I just assembled them. Okay. When I operate mathematically, you must see here. This is 3 cross 5. This is 5 cross 5. This is 5 cross 3. Final matrix dimension will be rows of this, columns of this. It should be 3 cross 3 at the end. You can see from this. How many buckets are here? Physically 4. 1, 2, 3, 4. Minus the 1. It counts with 3. So 3 cross 3 is your Y bus. Minus 1 is because of one of the references taken out to transform the parameter and variable by using singularity of that matrix A into Y bus. Hence, one less you count it as bus number. Therefore, when I take a product of this, you can operate these two first, take the conclusion of that with the first one or first two, because you can multiply anyone. This you can multiply, keep ready with that, or keep these two multiplied, take the first one. Whichever is convenient, you can definitely do. On whose reduction, you will be able to get 3 cross 3 matrix. So which I'll be writing it as a 3 cross 3 matrix by the answer numerically, if I am not wrong, it is minus J 8.028 208 J 0.2083. So this can be justified using calculator and MATLAB. If you are familiar with the MATLAB, it's very advisable because MATLAB is one of the scientific programming tool which you can refer in our laboratory as well as in your practice, which is very necessary. J 5.0. I just put a bracket over here, and the second is minus J 4.0833 J 2.0 and J 2.0. This is minus J 7.0. This will be the answer. So no matter which problem you are solving, how complex is that, doesn't make any problem. You can definitely work it out with the simple. You can see the work at the end. It is just a 3 cross 3 9 element matrix. Initially we began a very large matrix of 5 cross 5. We worked as an impedance, we took an inversion, we conveyed ourselves, a lot of techniques are required, and we need to practice those large matrix inversion methods. Once you get that content transformed into primitive admittance, then we took ourselves to obtain A matrix directly without forming A cap. This is how we gained competency in making ourselves to the numerical problem. Once we get A, writing A transpose, making the arrangement on a particular location would make you comfortable. So this way, when I work a mutual coupled case, we can do. I sincerely request you, the similar problem, if you could work on paper on your own with some calculator or your MATLAB reference, you will be still confident of making any problem approach. Now I suggest on this problem, mutual couplings were mentioned in the problem with element number 2 and element number 1, element number 4 and element number 1. The same thing you can try, delete that last column, other elements, you can consider them as coupled mutually, or the dash which I mentioned, there you position yourself J.1 with some number of elements, J.2 some number element. What is wrong? Making the Z PRI full house matrix, taking a full house matrix inversion as a YPRI, making the numerical calculation worked out. We can even make initiation trying to use computer for this work. Hence, it was a subject earlier known as computer techniques in power system analysis only. Earlier to your 15th scheme, now you are in 17th scheme. It was called as computer techniques in power system analysis only, wherein lot of numerical methods, computation techniques were used to resolve the complexity of the power system problems. No matter the title is power system analysis 2, but still it involves computer to resolve the complexity. I sincerely suggest you please look for such tools which enhance our competency and skills in approaching such numerical problems. Now I would like to take one more problem with the PowerPoint presentation, wherein that problem already we have undergone without mutual coupling concept. If mutual coupling concept is considered on the similar problem, how would ZPRI and YPRI concepts, which just now we understood on the board, is visualized on those PowerPoint slides? You can capture your attention and get more confidence on that kind of work. Okay. Now I will switch from this problem to a PowerPoint where you have one more problem to observe and understand. So hope this problem outlined which the convention method which I said is clear to you all. Somebody reply to me. You are able to get the problem which we discussed on the board, at least on the front, which the sequential way how I followed till the end of the Y bus is what I have pronounced, what I am following is matching with your requirement. Somebody would reply to me so that I can go next to the PowerPoint slide presentation to you for another problem. Can I consider it? Can I consider? Please convey me.
Sir, that diagonal elements should be plus, no sir, positive it should.
I'll come to you. The diagonal element over here in this regard you are asking, no?
Yes, sir.
Why you are not getting diagonal like this way? Am I right?
Yes.
Okay, don't worry about this. I'm sure your attention is why diagonal elements are minus over here. Am I right? Am I right with your question? Why diagonal elements are minus over here?
Yes, sir.
Okay, I'll tell you very simple. If you have an impedance, 1 by impedance if you take, you are going to get admittance. Am I right with this basic principle?
Yes, sir.
Okay. Now, you have an impedance 1 divided by j.5 or 1 divided by j1, we can say. 1 divided by j1. You take an inverse of it. How do you take? Usually, you make a rationalization, like multiplying it by complex conjugate of j1. It is called minus j1 divided by minus j1. Multiply with this. Am I right? To get a complex conjugate, how you do rationalization of thirds and this complex number? Suppose it is 1 by z1. How do you make it numerical? Into that particular complex conjugate, the numerator, denominator, and you get it analytically on the paper. But if you work in the calculator, 1 by z1 is directly by inverse. At that time, j square when you take, it become minus 1. J square when you take, it become minus 1 at the denominator. That minus 1 automatically turn into numerator. Hence, minus comes back. Hope I'll convince that. If you have a number 1 divided by j1. Okay? 1 divided by j1 when you inverse, what you are going to get? 1 divided by j1 in the calculator, or else you can do 1 divided by 0 plus j1 in the calculator. You take an inverse, you will get minus number on the numerator. It is because, very true, how do you take by analog work? On the paper, you will take 1 divided by 0 plus j1 multiplied by complex conjugate of the particular value. Am I right? When you multiply with the complex conjugate, when you multiply in the denominator, when you multiply in the numerator, you will have minus from the denominator. That comes to the numerator. Hence, minus comes back. Hope this justified you.
Yes, sir.
It is because your observation is perfect. There is no doubt about it. We have the data in impedance. When I convert impedance to admittance, negative comes out. There is no question about it. You are correct. Your question is correct. Minus is 100% over there because of the 1 divided by z. When I operate, it will lead me minus over there. Suppose you have a large number, it might be vanished because of some other series parallel combination of impedances, that minus may go off. Right now you are finding only diagonal minus. I am very clear about your observation. Yes, it is right. Because of 1 divided by z, minus is visualized. Such minus elements you are adding, minus with the minus of, so minus j1, minus j2, it becomes minus j3 only when I add admittances. In that way, on the diagonal, you are quite sure you are getting minus 1. Sure? In this case, okay? So, I will switch to PowerPoint so that I can make some more interaction with you and we can make one more problem convince to you. Okay? I just take this screen and I make you visualize this particular. Okay. Hope the screen is visible to you, please. Somebody please reply to me. Somebody reply to me. This screen, example 2.1 is visible to you all?
Visible, sir.
Okay, thank you then. This was the problem. I come to you. This was the problem we have seen earlier. No matter. This was the problem we have seen earlier. But see the problem with a different perspective. I read out the problem for the clarity. Consider the power network shown in figure 2.2. The ground bus is marked as 0 or it is a reference. Grounding the impedances at buses 1, 2, 3. It means to say representation from bus 1 to ground, bus 2 to ground, bus 4 to ground. Generator information is given as J.6 ohm, J.4 ohm, J.5 ohm respectively. Nothing but generators representation. When I represent voltage source topology, current source topology, you will come across impedance or admittance of the element. No matter whether it is an representation by alternative method, the value from bus 1 to ground, bus 2 to ground, bus 4 to ground were mentioned as ohmic 0.6J, 0.4J, 0.5J. Next, he has given impedances of the elements. Element between 3 and 4, element between 2 and 3, element between 1 and 2, element between 2 and 4 were mentioned with the impedance J.25, J.2 ohm, J.2 ohm and J.5 ohm. This was the original problem with which obtain Y bus by singular transformation was our initial work we tried in the earlier class. Now, addition to that, read this new line. The mutual impedance between the elements between 2, 3, bus number 2 to 3 connectivity and 2-4, 2 to 4 connectivity is J.1. Now, what is the meaning of this one? In the problem which we just now worked on the board, there were two elements coupled mutually. Element number 2 was coupled with element number 1 and element number 4 was coupled with element number 1. Like that, you have only one connectivity. 2 to 3 element is mutually coupled with 2 to 4. That's all. The work in this problem is less than what we did on the board. So coupling is between only two transmission lines. Earlier problem on the board was having two networks of such, means two such configuration. So having this mutual impedance J.1, obtain Y bus of this system using singular transformation method. Then what is my next approach? Y bus equal to A transpose Y primitive into A. That's the standard equation I should refer. I have to prepare A matrix of this problem. Then I have to prepare Y PRI of this problem. Before preparing Y PRI, I should check whether the data is given in the form of impedance or admittance. No doubt in this problem, impedance is given in impedance form instead of admittance. Hence, I should be very careful. It is ZPRI, Z primitive, I must frame first. Then take inverse of that to get YPRI. This is the care one should take, because I have seen in the earlier semesters of your seniors, people just did a small ignorance over here. They took it as a Y and they solved the problem. Just imagine 8 marks worth problem where there is a scope for us to grade your performance. You are just lost in the initial stage only. Instead of taking ZPRI, by mistake you consider them as a YPRI, entire work went in a different way. You might have solved a different problem like that. Therefore, attention must be paid to the numerical units, whether it is a ohm or a mho. You must be careful. I'm sure here it is ohm. I should take ZPRI. From the ZPRI, I must be preparing YPRI. If I want to make it, now I'll pass the next slide. Can you see this? Will this look like a resembling work for you? Earlier, we have seen this graphical representation. To form and understand a matrix, to just recall back, to obtain impedance matrix of the problem, this problem was taken to your notice. You have 4 distinct buses, ground as reference. At the bottommost of the graphical presentation, OR0 is mentioned. Bus number 1, bus number 2, bus number 3, bus number 4, you will find. And you will find line segments connected between reference and 1 to show you a generator 0.6J. You have bus number 2 and a generator J.4 ohm, a line segment. Bus number 4, a generator with a J.5. So you have 3 data of generator, vertically upward arrows you will find. So we have discussed a lot. Arrows may be given downward or upward, or you have a choice of picking. If it is given to you, you must adhere. If not given, you have a choice of taking yourself. In this problem, it has been taken by the author. We will just practice him and we will take the conclusion from that. Once it is marked, go back to the electrical network. Bus 1 to 2, there is a transformer and there is a transmission representation, which is given by J.2, 2 to 3, and 3 to 4, and 2 to 4. You just count the number. Element number 1, element number 2, element number 3, 4, 5, 6, 7. All these elements were given with J information. J.2, J.4, J.5, J.25, J.2, J.2, J.7, 0.5, and there is an additional information mentioned with a flower bracket. Can you see that flower bracket? Element between bus 2 and 3 and bus 2 and 4 is shown with a flower bracket. Those 2 transmission lines are mutually coupled by J.1 is an indication graphically, which was mentioned in the problem. What was mentioned? Element between 2, 3 and 2, 4 are J.1 ohm mutually coupled. That coupling is shown by a central write-up. Between those 2 lines, you have J.1. So now, once you have all the information in the form of impedance, now my next task is to generate ZPRI matrix. I cannot prepare YPRI directly. You might ask me, if I convert manually one by one place over there, and mutual impedance of J.1, 1 divided by J.1, I convert to mutual admittance, I place them there. Can I work it out? Absolutely a wrong step. Don't do that mistake. When there is a mutual coupling, you must follow standard syntax of placing them in impedance matrix only. From that impedance matrix, if there is a coupling, inversion is highly required. You cannot do local inversion element by element unless it is only diagonal representation. If it is a diagonal, you have freedom of taking one by like that. If there is a mutual coupling, please do not commit that mistake. So next work is to represent these elements on main diagonal, that is the element, and off diagonal, the mutual coupling. Can you observe there? All the elements, 1 cross 1, element 1, 2 cross 2, value of element number 2, so-called element number 7. All the elemental impedances are put on the diagonal. That is just a main diagonal. Look at the element which is 5 cross 7, 5th row, 7th column. On the 5th row, 7th column, you have J.1. You might ask me why J is not there. Can you see that? J is taken out for mathematical simplicity, and after completing the task, J is brought in. Some people do this way also. But on board we have not done. We use J inside the matrix itself. It's a once practice. So 5 cross 7 is 0.1. Same way you can see 7 cross 5 also 0.1. These two elements are non-zero. It shows there are two transmission lines coupled each other. So two elements are non-zero. If two more elements are coupled, two more elements are non-zero. One coupling will create two elements non-zero. Second coupling creates two more elements. Like that, you will have the empty spaces which is shown, which is to be filled with 0. So they become representation with the numerical content. Hope this ZPRI matrix from the problem is clear to you all. Like what the problem which you have seen on the board. No matter a larger or a bigger problem is taken over here, whose ZPRI is obtained from observation. Once this ZPRI is ready, may I know what is the next step? It's an impedance. I should convert this to admittance by taking inverse of this matrix. So therefore, some techniques of Gauss elimination, Gauss-Jordan method, or diagonalization or triangle elimination techniques must be applied to get inverse of a 7 cross 7 large matrix. There is one more method called as partial inversion, cutting this entire 7 matrix into small matrices of maximum 3 cross 3, less than 3, maximum of 3. Using calci, you can do that. So you need to research your learnings of matrices and inversion of large matrix. Okay, we'll see it once again in the laboratory perspective also. Once ZPRI is ready, my next step is to obtain YPR. Can you see here? It is ready for me one click in MATLAB. If I am familiar in the MATLAB approach when I am working on a laboratory, for me it is just a command line command, just INV Z, give me Y. Can you see there minus? So one of your friend asked me why minus comes over there. Is the minus outside minus J is witness to you? Yes, it should be. So your question was absolutely correct over there. You can witness there minus comes out here. When I take 1 by a J1, J2, J5, when you take into numerator, it becomes J square. In the denominator, J square becomes minus 1 get attributed to numerator, that is taken common from other side. Okay, this is the practice. Now, once YPRI is ready, my next step is to understand how do I get A matrix of that. So for this problem, if I take you back, how A matrix can be framed, I go back to the previous interaction what we did. How to obtain A matrix of this? We have done it. Okay. So for this matrix, the same problem I am coming back. We have 7 elements. You will have row wise when I go down 1, 2, 3, 4, 5, 6, 7. Column wise when I move apart, I have total 5 countable buses. Total 5 countable buses, but the first bus which is 0 is a reference. I do not consider that. I will not work anything with respect to 0. Remaining buses 1, 2, 3, 4, I consider for my work to reduce my work and obtain A directly. The first column refers to bus number 1 in this. At bus number 1, how many elements you have interacting? 1 and 6. 1 is inward, it is minus 1. You can see there. 6 is outward, 6th row is plus 1. Similarly, when I go to bus number 2, 2, 5, 6, 7. 4 elements are there. You can see that. 4 elements are non-zero and remaining 3 are 0, blank. So which is minus 1, which is plus 1? You can use the rule. So you can surely see 2 are incoming, 2 are outgoing. It witnesses you. At bus 3, 4 and 5, both are incoming, both are minus. At bus number 4, you have 3 lines. 3 is incoming, it must be minus 1. 4 is outgoing, it must be plus 1. And 7 is incoming, it must be minus 1. So no matter which, however the big or complex problem is that graphically it is quite easy for you to get into. Therefore, this A matrix, after having the reference column content bypassed, I have not at all prepared for that. So it may be any bus said in the problem, you must be able to skip that calculation and remaining calculation you can put in the form of matrix. You are able to complete your task. So I hope this is recalled to you. We have done it in the previous weeks itself. The same problem when I revisit over here, I have readily available A matrix. The same matrix I took here. Now I have YPRI, I have a A with me. What is my next task? A transpose into Y into A. I should operate mathematically. Can you see that? But here, can you see a small shift in my work? A transpose I put wrongly. The first and last matrix I should interchange. Can you see over there? Can you see over there? First matrix and last matrix I did not exchange. I kept blank by mistake. So first matrix and last matrix should be replaced in the position. A transpose YPRI into A. No matter, it will work because of mathematical dimension, it is possible. So once I operate it, I will be able to get matrix of Y bus equal to A transpose YPRI into A as a particular dimension of 4 cross 4. Because there were total 5 buses, 0 was eliminated, remaining were 4, and the dimension is 4 cross 4. This